ये कौन है?
बच्चों को आप कंट्रोल करें, ठीक है।
लिंक
ठीक है। कितने स्टूडेंट्स आ गए हैं?
सर ये 30 आ गए।
30 आ गए हैं। ठीक है। क्लास रिप्रेजेंटेटिव है कि नहीं है? जी
नहीं है सर जी, नहीं है।
क्लास रिप्रेजेंटेटिव नहीं है क्लास में?
नो सर।
अच्छा, तो आप लोग का पेपर जो है ना,
तुम यार हेडफोन लगाओ तो सही।
आप लोगों का पेपर स्टार्ट होगा कब, आपको पता है?
10 बजे सर।
यस सर, 10
हाँ,
बजे।
10 बजे स्टार्ट होगा। जबरदस्त, ठीक है।
सर वो डेट शीट में तो 12 बजे टाइम है, तो सारे पेपर 10 बजे होंगे या सिर्फ ये वाले पेपर 10 बजे हैं?
नहीं, मेरा पेपर जो है ना वो 10 बजे होगा।
ओके सर।
ठीक है, मेरा पेपर 10 बजे होगा।
तो अदर्स के साथ ग्रुप में नहीं है ना, उस ग्रुप में
जी
नहीं, ये मेरे अपने, मेरे को क्या पता।
कितने स्टूडेंट्स आ गए?
34।
34 से ज्यादा नहीं आते हैं, आज भी नहीं आ रहे, हालांकि इनका पेपर है। अच्छा, इस तरह है कि आप लोग का पेपर जो है मंडे को स्टार्ट होगा 10 बजे। ठीक है,
यस सर।
और
जी सर।
पेपर 3 घंटे का होगा। ठीक है,
यस सर। यस
ठीक है सर।
ठीक है।
आप लोग अपने साथ जो है ना, मतलब एक ब्लैंक शीट्स रखेंगे। सबसे पहले पेपर को सॉल्व करना होगा प्रॉपरली ब्लैंक शीट्स पे। ब्लैंक शीट्स भी आप लोग गूगल क्लासरूम पे सबमिट करेंगे, और उसके बाद है मतलब लाइक आंसर बुक में जाके करेक्ट आंसर को सेलेक्ट करेंगे और करेक्ट आंसर को भी आप सबमिट करेंगे। ठीक है, ठीक है।
इसका मतलब ये है कि सारे एमसीक्यूज हो गए, हम सारे एमसीक्यूज को सॉल्व करेंगे, उसमें वही ऑप्शन भी लिखेंगे, वो दोबारा आपको वो सबमिट करेंगे।
प्रॉपर क्वेश्चंस होंगे, उन प्रॉपर क्वेश्चंस को आपने सॉल्व करना होगा। उनके स्क्रीनशॉट्स को भी सबमिट करना होगा आपने गूगल क्लासरूम में।
जी सर।
समझ आ रही है? और फिर मतलब उसमें जो न्यूमेरिकल क्वेश्चंस हैं वो आप लोगों ने सॉल्व किए होंगे। अपने आंसर को फिर मतलब उसमें जाके आंसर बुक में जाके अपने आंसर को कंपेयर करें करेक्ट आंसर के साथ, और आंसर बुक में करेक्ट आंसर को भी टिक करें। तो 2 काम करने होंगे। नंबर 1, सबसे पहले पेपर को सॉल्व करना होगा, सॉल्व पेपर का स्क्रीनशॉट सबमिट करना होगा, और फिर जो है मतलब आंसर बुक में जाके उसमें जो न्यूमेरिकल क्वेश्चंस है उन न्यूमेरिकल क्वेश्चंस के करेक्ट आंसर को सेलेक्ट करके आंसर बुक को भी सबमिट करना होगा। ठीक है,
ओके सर।
ओके सर।
ओके ओके जी। सबसे पहले मतलब हम इलेक्ट्रिकल एनर्जी की बात करते हैं चैप्टर नंबर 4 में। तो चैप्टर नंबर 4 में we assume कि यहाँ पे हमारे पास एक source है. Let's say we have got a source and the source is represented by Q1. And we select 2 points. We select 2 points in the field of this particular source. This is point A, and here is another point which is represented by B. So these 2 points are located in the field of the source, right? These 2 points are located in the field of the source. So ये 2 points जो है मतलब they are located in the field of the source. There will be electric field intensity in this particular region, and this electric field intensity is caused by this particular source. So if you guys want to move a charge of Q coulomb from the initial position B to the final position A against the field of the given source, you guys will need some external source of energy. You guys will need some energy to move this charge of Q coulomb from the initial position A to the final, from the initial position B to the final position A. So some energy will be required, and we need to calculate, you see, that particular energy. So the energy which is required to move a charge of Q coulomb from the initial position from the initial position B to the final position A against the field of the source can be calculated with the help of this particular integration. And what is dl? dl is the differential link vector in the direction of the electric field intensity. So you guys can calculate the energy which is required to move this charge of Q coulomb from the initial position B to the final position A against the field of this particular source. And the magnitude of this charge should be known, the electric field intensity of this source should be known, and you guys need to find out the differential link vector, and keep it in your mind that this differential link vector is always in the direction of the electric field intensity. So we want to find out voltage or we want to find out the voltage or the potential difference between these 2 points. So definitely there will be some voltage between point A and point B due to this particular source, and we need to find out, you see, this voltage. Voltage is electrical energy as well, right? So if you want to find out the voltage between point A and point B, what we do, we place a unit positive charge over here. So we place a unit positive charge over here. The amount of energy which is required to move a unit positive charge from the initial position B to the final position A against the source, against the electric field intensity of the source, will be known as potential difference between these 2 points, or will be known as the voltage between these 2 points. So now, instead of a charge of Q coulomb, we move a charge of 1 coulomb. So you guys will have to replace the charge of Q coulomb by a charge of 1 coulomb. And once you move a charge of 1 coulomb from the initial position B to the final position A against the field of the source, the amount of energy will be equal to the voltage or the potential difference between these 2 points. So you guys can calculate the voltage or the potential difference between these 2 points with the help of this particular integration. Well, when we calculate the energy which is required to move a charge from one position to another position in a given field, or once we calculate, you see, the voltage between the 2 points in an electric field, we discuss another a topic as well, which is known as the line integral. So the topic of the line integral is very important for the numerical questions. So let us talk about, you see, the line integral. For the line integral, we consider uniform electric field over here. We consider 2 points, point B and point A. And we assume that these 2 points are located. Abdullah? Abdullah?
Yes, sir. Yes, sir.
आप ऐसा करें, जिनके माइक्रोफोन्स आने उनके माइक्रोफोन्स बंद करें और जो ज्यादा डिस्टरबेंस क्रिएट करते हैं उनको किक आउट करें क्लासरूम से, ठीक है?
सही है सर जी.
So we consider 2 points and we assume that these 2 points are located in a uniform electric field. And what we do, we move a charge of q coulomb from the initial position B to the final position A in this uniform electric field. So if you guys want to move this charge of q coulomb from this point to this point in the given uniform electric field, you guys will need some energy. So you guys will have to calculate, you see, this electrical energy. ये जो electrical energy है, अपनी convenience के खातिर you guys can choose any path between these 2 points. You see, you guys can move this charge along this particular path as well, or you guys can move this charge of q coulomb along the straight path between point A and B. So this is up to you. You guys can select, you see, any path between these 2 points. You guys can select a zigzag path between these 2 points, or you guys can select a straight path between these 2 points, or you guys can consider a circular path between these 2 points. So this is up to you. Anyhow, basically energy जो है वो सिर्फ इस रास्ते पे डिपेंड करती है, the minimum distance between the 2 points. So the amount of energy which will be required to move this charge of q coulomb from the initial position B to the final position A along any path in this field. Path जो है, that is up to you guys. You guys can choose any path for your convenience. So basically, if you guys want to calculate it, what we do, we consider a very small distance vector along the straight path between these 2 points. And this differential link vector is represented by dl. So the amount of energy which is required to move this charge of q coulomb from the initial position B to the final position A in this uniform electric field can be calculated with the help of this integration. So you guys can use this particular integration to find out, you see, the energy which is required to move this charge of q coulomb from the initial position B to the final position A. और मैंने बता दिया आप लोगों को कि you guys can choose any path between these 2 points. Anyhow, as the electric field intensity is uniform, so if the electric field intensity is uniform, we can consider the electric field intensity over here. This is the electric field intensity, and we integrate the differential link vector from point B to point A. So what does it mean? It means that we have divided this straight path into a very large number of very small differential vectors. और इन तमाम differential vectors को अगर आप लोग add करेंगे तो आप लोग के पास क्या आएगा? You guys will get, you see, the distance between these 2 points. You guys will get the resultant vector over here, which is represented by LBA. So LBA represents the vector which extends from this point to this particular point. So definitely the integration of DL will give you LBA. So you guys can calculate this energy with the help of this particular equation as well. We have minus Q, and then we have the electric field intensity, and then we have dot LBA. So this much energy will be required to move this charge of q coulomb from the initial position B to the final position A, or you guys can choose any path for your convenience. You guys can choose a straight path between these 2 points, or you guys can consider a curved path between these 2 points, or you guys can consider a zigzag path between these 2 points. So you see, अपनी आसानी की खातिर आप लोग इन 2 पॉइंट्स के दरम्यान कोई भी रास्ता इख्तियार कर सकते हैं, और अपनी आसानी की खातिर उसी रास्ते पे इस चार्ज ऑफ q कूलम को इस यूनिफॉर्म इलेक्ट्रिक फील्ड में लेके जाएं, calculate the energy along that particular path, and you guys will be able to get the energy. Similarly, potential difference जो है, potential difference between these 2 points is energy as well. So if you guys are asked to calculate the potential difference between these 2 points, you guys will have to calculate the energy which is required to move a unit positive charge from this point to this point against the field. And you guys can choose any path between these 2 points for the calculation of the voltage as well, because voltage is energy as well. तो कुछ numerical questions जो है हम करते हैं, और उन numerical questions में हम 2 points के दरमियान जो है स्ट्रेट लाइन सेगमेंट्स कंसीडर करते हैं, क्योंकि हमारे लिए स्ट्रेट लाइन सेगमेंट्स की मदद से न्यूमेरिकल क्वेश्चंस को सॉल्व करना इंतहाई आसान है. ठीक है, ठीक है जी.
यस सर.
ठीक है जी. कितने स्टूडेंट्स हैं?
40 है सर जी.
38.
48.
40 है. 40.
39.
ठीक है. 39 तो मेरे साथ, 40 मेरे साथ होंगे ना. Now what we do, we consider a point charge of q coulomb. Let's say हमारे पास एक source है which is in the form of a point charge, and the magnitude of the charge of this particular source is q coulomb, and we select 2 points we select 2 points in the field of the source. Let's say this point is represented by A and this point is represented by B. So we consider 2 points in the field of this particular source, and we want to calculate the voltage between these 2 points, the voltage due to this particular source. So in order to calculate the voltage between these 2 points, we assume that the radial distance between point A and the source is given by RA, and the radial distance between point B and the source is RB. So if RA is the radial distance of point A with respect to the source, and RB is the radial distance of point B with respect to the source, then the voltage between these 2 points will be equal to Q divided by 4 pi epsilon, and then we have 1 over RA minus 1 over RB. So we can calculate the voltage between these 2 points with the help of this particular equation as well. Q is the magnitude of the charge of the source. You see epsilon is the permittivity of the medium where the source and the points are located. RA is the radial distance of point A with respect to the source. RB is the radial distance of point B with respect to the source. So you guys can use this particular equation to calculate, you see, the voltage between these 2 points. You see, if you guys want to calculate the potential at this particular point, so the potential at point A will be equal to Q divided by 4 pi epsilon RA. So this gives you the potential at this gives you the absolute potential at point A, and you know the definition of the absolute potential. How do we define the absolute potential? We say that the amount of energy which is required to move a unit positive charge from infinity to this particular point. So the reference point will be infinity. So you bring a unit positive charge from infinity to this particular point, and this energy is basically equal to the absolute potential at this particular point. So this is the absolute potential at this particular point. Similarly, the absolute potential at point B will be equal to Q divided by 4 pi epsilon RB. So this is how we calculate the potential at point B. So generally, if you guys want to calculate the potential at a point due to this point charge, we use this particular equation, Q divided by 4 pi epsilon R. So R is the radial distance between the source and the point under observation. So you guys can calculate the absolute potential with the help of, you see, this particular equation. If you guys want to calculate the potential at any point, you guys need to know the magnitude of the charge of the source. You guys need to know the permittivity of the medium, and you guys need to know the radial distance between the source and the point. So this is how we calculate, you see, the voltage between point A and B, and this voltage is caused by this particular source. The source is in the form of a point charge. This is how we calculate the potential at point A. This is how we calculate the potential at point B, and this is how we calculate the potential at a general point P. And now, let's say we consider another diagram. We consider the source, which is in the form of a point charge, and we consider another point over here, which is represented by P, and we want to calculate the potential at this particular point. And now we consider the position vector of the source, which is R1. So R1 is the position vector of the source. Here is the origin. And R is the position vector of the point under observation. So अगर आप लोग इस equation पे नजर डाल दें, you see the potential at any point will be equal to Q. So we know the magnitude of the charge of the source, which is Q, and then divided by 4 pi epsilon. So ये तो constant है. And then we need R. And you see what is R? R is the radial distance between the source and the point under observation. Now the distance between the source and the point under observation is given by this particular line. So basically आप लोग क्या करेंगे? You guys will have to calculate the magnitude of this particular vector. So you guys will have to calculate the vector R minus R1, and then you guys will have to calculate its magnitude. So if you know the distance between the source and the point under observation, you guys can calculate the absolute potential at the point under observation. So this will be the absolute potential at the point under observation. Now, R minus R1 in this particular equation represents the distance between the source and the point under observation. So this is how we calculate the potential due to what? Due to a point charge. Now what we do, we consider a line charge now. Let us consider a line charge. हम क्या consider कर रहे हैं?
Line charge.
Line charge. Okay, so what we do, we consider a line charge. We assume that the charge is uniformly distributed along this line. So we consider a line charge over here. So we assume that the charge is uniformly distributed along the length of this line. Okay. And the line charge density of the source is known, which is basically equal to rho L. And we consider a very small portion of the source over here. We know that the length of the small portion will be dl, and the magnitude of the charge on the small portion of the source will be dq, right?
DQ. Yes,
So, so dq, the differential charge on the small portion of the source will be equal to rho L dl. So this will be the differential charge on the small portion of the source. So what you guys will have to do, you guys will have to calculate the differential potential at this particular point, and this differential potential will be caused by the small portion of the source. So we consider the small portion of the source first, and we calculate the differential portion which is caused by the differential charge on the small portion of the source. So exactly वही equation था, हमारे पास v के लिए equation था, उसको हमने dv में convert कर दिया. So this is the differential potential at this particular point, and this differential potential is caused by the small portion of the source, and you know that the magnitude of the charge on the small portion of the source is what?
DQ.
DQ.
dq. So what we do, we replace this dq by rho L dl. we know that the differential charge will be equal to rho LdL. So we put the value of the differential charge in this particular equation, and then we integrate it. So just put the value of the differential charge on the right hand side of this equation, which is
OLDL.
rho L dl, and then integrate the same equation. So we have 4 pi epsilon, and then we have r minus r1. This is the distance between the small portion of the source and
Point.
the point under observation. So basically, we use this particular integration to find out the potential at this particular point. And the potential at this particular point is caused by the line charge now. So ये याद रखें, if the dielectric constant of the medium is not given to you guys in the numerical questions, तो फिर आप लोग assume करेंगे कि source and the point under observation are in the free space. So you guys will have to replace this epsilon by epsilon naught. समझ आ रही है?
Yes, sir.
If the dielectric constant of the medium is not given to you guys, what is the dielectric constant? This is basically the relative permittivity of the medium. So if the relative permittivity is not given to you guys in the numerical questions, you guys will have to assume that the point and the source are located in the free space, and you guys will have to replace this symbol by epsilon naught. So this is how we calculate the potential at the given point due to a line charge. Let us consider a surface charge. So basically, in the equation में, we make changes in this particular equation to find out the potential at this particular point due to the surface charge. Instead of a line charge, we consider a surface charge now. We assume that the charge is uniformly distributed in the given area. We assume that the charge is uniformly distributed in the given area. आप लोग को नजर आ रहा है?
Yes, sir.
Can you guys see the diagram?
Yes, sir.
बिल्कुल, sir.
We assume that the charge is uniformly distributed on the given area. Then we consider a small portion of the source, and the area of the small portion is ds. The magnitude of the charge on the small portion is dq. And we assume that the surface charge density of the source is known as well, which is rho s. So now the differential charge on the small portion of the source will be equal to rho s. The differential charge will be equal to rho s. आप लोग सो रहे?
No, sir.
Rho S ds.
The differential charge. I am waiting for your response. So जब मैं खामोश हो जाऊँ, आप लोग मुझे response दे. So the differential charge on the small portion of the source will be equal to rho s ds. We want to calculate the potential at this particular point, and we will calculate the potential at this particular point with the help of the small portion of the source. So what we do, we consider the small portion of the source, and we calculate the differential potential at this particular point. So the differential potential at point P will be equal to dq divided by 4 pi epsilon, and then we have r minus r1. What is r minus r1? R minus
Distance
r1
between.
is the distance between the small portion of the source
and point under observation.
Bilkul. So now what we do, now we replace this differential charge by rho s ds. We can calculate the differential charge on the small portion of the source with the help of rho s, which is the surface charge density of the source, and ds. What is ds? ds is the area of the small portion. So we put the value of the differential charge on the right hand side of this equation. So सबसे पहले just put the value of the differential charge on the right hand side of this particular equation, and then integrate this equation. The integration of this equation will give you the potential at this particular point, and this potential is caused by this particular source. The source is in the form of a surface charge. So यहाँ पे you guys will have to use this particular integration, and याद रखें कि differential area involved है इसमें. Differential area is always in terms of two parameters, dx dy.
Double integration.
Yeah, so this will be double integration. Very
Yes,
good.
sir.
और अगर numerical questions आप लोग के पास है जिसमें the relative permittivity of the medium is unknown, you guys will have to assume that the source as well as the point under observation are located in
फ्री स्पेस
Free
Free
space.
space.
free space. तो चीज ध्यान में रखें कि जिस numerical question में dielectric constant is not given to you guys will have to assume that the medium is free space. और ये भी याद रखें कि 1/4 pi epsilon naught. If the source and the point are located in free space, so 1/4 pi epsilon naught is basically
9 into
equal
10
to a
power 9.
constant, 9 into 10 raised to power 9. This is basically equal to this particular constant. So this is how we calculate the potential at the given point due to the surface charge. Now let us talk about a volume charge. So we assume that the charge is uniformly distributed in a volume. So now you guys will have to consider a volume. So let us consider this charge in the form of a volume over here. We assume that the charge is uniformly distributed in this volume. So the charge is uniformly distributed inside this volume, and the volume charge density of the source is known. So the rho v represents the volume charge density of the source. dV in this diagram represents the differential volume of the small portion of this volume charge, and d cube represents the charge inside the differential volume, the charge inside the small portion of the source. R1 is the position vector of the small portion of the source. R is the position vector of the point under observation, and this notation represents the distance between the small portion of the source and this particular point. So if you guys want to calculate the potential at this particular point, which is caused by the volume charge, the source is in the form of volume charge now. You guys will have to consider the small portion of the source first. So definitely the potential at this particular point, which is caused by the small portion of the source, will be differential potential. तो यहाँ पे दो dV इन्वॉल्व है, दोनों का सिंबल्स चेंज रखें क्योंकि एक dV रिप्रेजेंट्स द डिफरेंशियल वॉल्यूम और दूसरा dV रिप्रेजेंट्स द डिफरेंशियल वोल्टेज. तो आप लोग की खिदमत में ये अर्ज है कि डिफरेंशियल वोल्टेज के लिए सिंबल थोड़ा सा डिफरेंट रखे और डिफरेंशियल वॉल्यूम के लिए सिंबल थोड़ा सा डिफरेंट रखे ताकि इन दोनों में आप लोग कंफ्यूज ना हो. वेरी गुड. So this is the differential volume of the source, और यहाँ पे this is the differential potential. So the differential potential, let me represent the differential potential by a symbol like this. इसको मैं change कर रहा हूँ. So the differential potential, which is caused by the small portion of the source, will be equal to dq divided by 4 pi epsilon, and then we have r minus r1. So what we do, we can calculate the differential charge inside the small portion of the source with the help of the volume charge density and the differential volume. So we know that the differential charge inside the small portion of the source will be equal to rho v dV. So if the volume charge density of the source is known and the differential volume of the small portion of the source is known, you guys can calculate the magnitude of the charge inside the small portion of the source.
Yes, sir.
इस बंदे को बाहर निकाल दे प्लीज, इसको म्यूट कर दे. अच्छा, so we calculate the differential potential at this particular point with the help of this particular equation, and this differential potential is caused by the charge inside the small portion of the source only. So what we do, we put the value of the differential charge. Now what is the value of the differential charge? It's rho v dV.
dV.
इसी equation में we put the value of the differential charge and then we integrate this particular equation. So we put the value of dq on the right hand side of the second last equation over here, and then we integrate this second last equation. The integration will give you the potential at this particular point. So this is how we calculate the
volume charge.
the potential at any point due to the volume charge. Well, we explained another topic in the video as well. And the video, if you watch the video, the topic is known as potential gradient. So we discussed another, please keep silence in the room. Where is our host?
Yes sir, mute कर दिया mute.
Host, you have the remote controller, so please mute them, okay?
सर ये 1 मिनट तो लगता है म्यूट करने में.
Okay.
ये सो रहा था होस्ट.
बस ये होस्ट जैसे हो जाता है ना, ये बुरी बात है. Potential gradient. We discussed this particular topic, which is known as potential gradient. Anyhow, this potential gradient is very important topic. Let's say I have a source over here, which is in the form of a point charge. So we have got a source over here. The source is in the form of a point charge. The magnitude of the charge of the source is q coulomb. And we consider a point at a radial distance r from the source. So we consider a point over here, and the radial distance between the source and the point is represented by r. So you know the potential at the given point will be equal to q, which is the magnitude of the charge of the source, divided by 4 pi epsilon, and then we have the radial distance between between the source and
The point.
the point. So this equation is used to find out the absolute potential at this particular point, and this absolute potential is caused by this particular source. The source is in the form of a point charge. The magnitude of the charge of the source is q coulomb. You see, you guys can calculate the electric field intensity at this particular point as well. ये याद रखें, the potential is a scalar quantity, isn't it?
Yes sir.
Potential is a scalar quantity. You guys need to know the magnitude of the potential only. You
Yes
don't
sir.
need its direction. So it's a scalar quantity. While electric field intensity is a vector quantity. Why? Because electric field intensity is an electric force. This is the electric force on a unit positive charge over here. If you place a unit positive charge over here at this particular point, there will be a force of repulsion on the unit positive charge due to this particular source. And the force on the unit positive charge at this particular point will be known as electric field intensity. So intensity is an electric force, and we know that force is a vector quantity. So electric field intensity is a vector quantity. You guys need to know the magnitude as well as the direction of the electric field intensity. So the electric field intensity will be equal to Q divided by 4 pi epsilon r square, and this electric field intensity will be in the direction of the unit vector AR. और ये याद रखें कि the unit vector AR will be in this direction. So अगर यहाँ पे आप लोग unit positive charge रखेंगे, the unit positive charge will move in the direction of the arrow. So the electric field intensity will be in the direction of the arrow. So this is how we calculate the electric field intensity at this particular point. So potential gradient is a very important topic. Why? Because if we know the potential at this particular point, as we know the potential at this particular point, we can calculate the gradient of the potential, and उस gradient of the potential को minus sign से ज़रब दे, and you guys will get to see the electric field intensity. So this is a very important relationship, which says that you guys can calculate the electric field intensity with the help of this important relationship, minus del V. Minus del V. This del V is known as the gradient of the potential. So if V is in the rectangular coordinate system, you guys can calculate the gradient of this scalar quantity with the help of this particular equation. We have curly V by curly X. We partially differentiate the absolute potential with respect to X if this absolute potential is in the rectangular coordinate system. And then we multiply it by the unit vector AX. Then we have curly V by curly Y into AY. We partially differentiate the potential with respect to Y, and we multiply it by the unit vector AY. And then we have plus curly V by curly Z. We partially differentiate this scalar quantity with respect to Z, and we multiply this derivative by this partial derivative by the unit vector AZ. So this is how we calculate the gradient of this scalar quantity in the rectangular coordinate system. Similarly, there is a formula which is used to calculate the gradient of this scalar quantity in cylindrical coordinate system. उस फार्मूले को आप जरा एक नजर देख ले. And then there is a formula which is used to calculate the gradient of this potential in the spherical coordinate system. If you look at this particular equation, this potential is in terms of R, and we know that R is a coordinate, is a parameter from the spherical coordinate system. So यहाँ पे आप लोग क्या करेंगे? You guys will have to calculate the gradient of this potential in the spherical coordinate system. Spherical coordinate system में इसके लिए खास फार्मूला है. वो फार्मूला जो है वीडियो में है. I have already explained the equations which are used to calculate the gradient of a scalar quantity in the rectangular coordinate system, cylindrical coordinate system, and spherical coordinate system. So if you calculate the gradient of this quantity, the gradient of this scalar quantity in the spherical coordinate system, and if you multiply it by -1, you guys will get this particular equation, which means that the electric field intensity is always equal to minus the gradient of the potential. So if you know the potential at any point, you guys can use this particular relationship to calculate the electric field intensity at that particular point, right?
Yes, sir.
ठीक है जी?
Yes, sir.
Okay. इस चैप्टर का जो आखिरी टॉपिक था, that was electric dipole. मुझे पता है कि किसी ने भी लेक्चर देखने की कोशिश नहीं की.
No, sir. हमने देखे. Sir जी
हमने देखी है.
The dot product of Q into D is known as electric.
बिल्कुल मुझे पता है. मुझे पता है कि जो लोग मेरे साथ ऑनलाइन मौजूद है इस वक्त, they know the lecture. लेकिन जो ऑफलाइन है, they know, they don't know the lecture at all, right?
Yes, sir.
So we talk about the electric dipole. We talk about the electric dipole. So let us consider that we have got two charged particles. This one is plus Q, and this one is minus Q. And the distance or the separation between these two is very small, which is represented by D. So we have got a positive charged particle of Q coulomb, and then a negative charged particle of minus Q coulomb. And the distance between these two charged particles is very small, which is represented by what?
D.
D. So if the distance between these two charged particles is very small, this arrangement is known as electric
Dipole.
So let us consider a point over here. So let's say this is the point under observation, and we want to calculate the potential at this particular point and the electric field intensity at this particular point. So the potential at this particular point will be caused by the electric dipole. Similarly, the electric field intensity at this particular point will be caused by the
Electric dipole.
electric dipole. So we assume that R is the radial distance between the center of the dipole and the point under observation. So basically, यहाँ पे आप लोग क्या करेंगे? यहाँ पे आप लोग रेडियल डिस्टेंस कैलकुलेट करेंगे डायपोल के सेंटर और पॉइंट अंडर ऑब्जर्वेशन के दरमियान. तो R is the radial distance between the center of the dipole and the point under observation. So if this is known, the potential at this particular point will be equal to QD cos theta, and then we have 4 pi epsilon r square. So we use this particular equation to find out, you see, the potential at this particular point, and the potential at this particular point is caused by this particular dipole. Q is the magnitude of the charge on any one of these two particles. D is the distance between these two charged particles. Theta will be given to you guys, and the distance between the center of the dipole and the point will be given to you guys. Okay?
Yes, sir.
Okay. So आप लोग इस इक्वेशन की मदद से भी एब्सोल्यूट पोटेंशियल कैलकुलेट कर सकते हैं, और आप लोग इस इक्वेशन की मदद से भी एब्सोल्यूट पोटेंशियल कैलकुलेट कर सकते हैं. The absolute potential will be equal to P, where P is known as dipole moment. So if we know the dipole moment, which is represented by P, so we have P, and then we have R. We consider the vector, we consider this particular vector, the vector which extends from the center of the dipole to the point under observation. And then we have 4 pi epsilon, and then we have R cube. So, so we can use this particular equation as well to calculate the absolute potential at this particular point. P is known as the dipole moment. So P is a vector quantity which is known as dipole moment, and this dipole moment will be equal to Q, which is the charge, which is the magnitude of the charge on any one of these two particles, multiplied by D. Is D ko, you guys will have to consider the distance between these two particles in the form of a vector quantity. We know that the distance between these two particles is represented by D, but you guys will have to represent this distance in the form of a vector quantity, and you guys will have to consider this vector in this direction. मेरे पास रहे. You see this vector, आप लोग को ये vector नजर आ रहा है?
Yes, sir.
Yes, sir.
This vector is extending from minus Q to
Plus Q.
plus Q. This will give you the direction of this vector quantity. So you guys will have to consider the distance between these 2 points in the form of a vector quantity. And this vector will be from the negative charge particles towards the
Positive charge.
positive charge particles. So this is how we calculate, you see, the dipole moment. So if you know the dipole moment, if it is not known, you guys can calculate it with the help of this particular equation. You guys will be given the magnitude of the charge on any one of these two particles. You guys will know the distance between these 2 points, and you guys can convert the distance between these 2 points into a vector quantity. And then this distance vector will be known. This is the vector which is extending from the center of the dipole to the point under observation. So you guys will use this particular equation to calculate the potential at this particular point. Then we calculate the electric field intensity, and we calculate the electric field intensity with the help of this relationship, this mathematical relationship. We know that minus the gradient of the potential will give you the electric field intensity. So you have the potential at this particular point, And if you focus on this particular equation, this potential is in the spherical coordinate system because this potential is in terms of r and theta. And these are two parameters from the spherical coordinate system. So यहाँ पे just calculate the gradient of the scalar quantity in the spherical coordinate system. I have already explained the equation or the formula which is used to calculate the gradient of this scalar quantity in the spherical coordinate system. So once you calculate the gradient of this scalar quantity in the spherical coordinate system, then you guys will have to multiply it by -1. And the right hand side of this equation will give you the electric field intensity. So the electric field intensity, well, let me use this particular space. So the electric field intensity will be equal to QD divided by 4 pi epsilon r cube. And then I think I have 2 sin theta. इसको जरा चेक कर ले, यहाँ पे cos theta है कि sin theta है?
cos theta sir जी.
सर cos theta है यार.
Cos theta है.
यहाँ पे 2 cos theta है, तो 2 cos theta AR
plus sin theta है sir.
plus sin theta A theta, right?
Yes sir.
Sin theta A theta. So you see, if you use this mathematical relationship, you guys will get this equation, and this equation is used to calculate the electric field intensity at this particular point. So if you have an electric dipole, you guys can use this particular equation to find out the electric field intensity at this particular point, and you guys can use any one of these two equations to calculate the potential at this particular point. Now, let me change the scenario. Let's say the center of the dipole, let's say R1 is the position vector of the center of the dipole. We have got the origin over here. आप लोग को नजर आ रहा है?
Yes sir.
So
Yes,
let's
sir.
say R1 is the position vector of the center of the dipole, and R जो है, that is the position vector of the point under observation. Here is R, which is the position vector of the point under observation. So we have changed the scenario now. Now R1, are you guys hearing me?
Yes sir. Yes sir.
R1 is the position vector of the center of the electric dipole. R is the
Position vector.
the position vector of the point under observation. If you focus on this particular equation, what is R? This equation में R is the vector which extends from the center of the dipole to
Point P.
this particular point P. So अब यहाँ पे ये जो vector है, the vector extending from the center of the dipole to the point under observation is R minus R1. Right?
Yes sir.
अच्छा, so इस equation को we modify this particular equation. So the potential at this particular point will be equal to P, which is the dipole moment, and then we have dot R minus R1. What is R minus R1? This is a vector which extends from the
Dipole.
which extends from the center of the dipole to this particular point, and then we have divided by 4 pi epsilon, and then we have R minus R1. R minus R1, or this notation basically gives you the magnitude of this particular distance vector. So you guys can calculate the potential at this particular point with the help of this particular equation. P जो है, this is the dipole moment. This dipole moment will either be given to you guys in the numerical question, or you guys will have to calculate it with the help of this particular equation. So या तो dipole moment directly आप लोगों को given होगा numerical question में, या फिर इस dipole moment को आप लोग इसी equation की मदद से find out करेंगे. And then we have R minus R1. What is R minus R1? The vector which extends from the center of the dipole to the point under observation. और ये भी याद रखें कि if the dielectric constant of if the dielectric constant of the medium is unknown, if the dielectric constant of the medium is unknown, you guys इस बंदे को म्यूट करे प्लीज।
यस सर म्यूट हो गया।
अच्छा, सो ये भी याद रखें कि मेजॉरिटी ऑफ द न्यूमेरिकल क्वेश्चंस में द डायलेक्ट्रिक कांस्टेंट ऑफ द मीडियम इज नॉट गिवन टू यू गाइस। तो आप लोग एज्यूम करेंगे ये जो अरेंजमेंट है, दिस अरेंजमेंट इज बेसिकली लोकेटेड इन फ्री स्पेस। तो यहाँ पे 1/4 पाई एप्सिलॉन नॉट की वैल्यू कितनी होगी? 9 × 10⁻9। 9. So this is the theory of chapter number 4. और इस chapter number 4 में जितने भी equations है, we have derived all the equations details में, and we have explained, you see, all the equations. ये just एक review था आप लोग के लिए। और फिर उसके बाद ये इस chapter के numerical questions भी, I have uploaded the numerical questions of chapter number 4. So hopefully you guys will go through the numerical questions as well. और inshallah सब students को बता दे कि the duration of the paper is 3 hours. The paper will start on upcoming Monday and it will start at 10 o'clock in the morning. Paper का जो time slot है, that is 3 hours. You guys will have to solve the paper on the blank sheets. और न्यूमेरिकल क्वेश्चंस को प्रॉपरली आप लोग ब्लैंक शीट्स पे सॉल्व करने की कोशिश करेंगे। यू गाइस विल हैव टू टेक द स्क्रीन शॉट्स ऑफ द सॉल्यूशन ऑफ द क्वेश्चंस। यू गाइस विल हैव टू अपलोड द स्क्रीन शॉट्स और उसके बाद जो है क्वेश्चन, सबसे पहले क्वेश्चन पेपर को आप लोग डाउनलोड करेंगे। क्वेश्चन पेपर के न्यूमेरिकल क्वेश्चंस को आप लोग सॉल्व करेंगे ब्लैंक शीट्स पे, उनके स्क्रीन शॉट्स लेके आप लोग अपलोड करेंगे गूगल क्लासरूम में। फिर आंसर बुक को डाउनलोड करेंगे और आंसर बुक में उन्हीं न्यूमेरिकल क्वेश्चंस के करेक्ट आंसर्स हैं। तो प्लीज आंसर बुक के करेक्ट आंसर को सेलेक्ट करने के बाद सबमिट द आंसर बुक टू द गूगल क्लासरूम एज वेल। सो इट विल बी an examination of 3 hours. I hope you guys will do the examination on Monday. You guys will make it inshallah. इस कोर्स से रिलेटेड चैप्टर नंबर 4 की थ्योरी से या न्यूमेरिकल क्वेश्चन से रिलेटेड, चैप्टर नंबर 3 की थ्योरी या न्यूमेरिकल क्वेश्चन से रिलेटेड, चैप्टर नंबर 2 की थ्योरी या न्यूमेरिकल क्वेश्चन से रिलेटेड, एंड सिमिलरली चैप्टर नंबर 1 की थ्योरी या न्यूमेरिकल क्वेश्चन से रिलेटेड अगर कोई क्वेश्चंस है, कोई कंफ्यूजन है तो आप लोग पूछ सकते हैं। जी मतलब वीडियो आप स्टॉप करें, ठीक है अब्दुल्ला?
यस सर कर रही।